start by analyzing the diagram that we see here. What do we see here? Do we see a motor or do we see a generator? So here we can see that we have a light bulb there, which is going to be using electricity. So it means if it's using electricity, it means that our device is producing electricity. It is a device that gives electricity. So if it is a device that gives electricity, therefore it's a generator. As we know that a generator will convert mechanical energy being converted to electrical energy there. So you can see that there's a coil there that is being turned, meaning movement energy, motion energy is being used to produce electrical energy there. So this will be a generator there. So the first thing that we identify is whether it's a motor or a generator. So it's a generator. And the second thing that we look at is that do we have slip rings or a commutator? And that will determine whether it's an AC generator or a DC generator there. So you see here, we have a split ring commutator there. So it's telling us that we have a DC generator there. Okay, 10.1 says now define the term generator. The generator will be a device. It's a device that converts. It's a device that converts now mechanical energy, movement energy, mechanical energy. It converts mechanical energy to give us electricity, electrical energy. It's a device that converts mechanical energy and converts that to electrical energy. Now 10.2 says what type of generator, AC or DC, is represented in the simplified diagram above. Give a reason for the answer there. Okay, once again, we see here is a split ring commutator. When we have a split ring commutator, we have a DC generator. So 10.2, the answer is that we have a direct current generator. We have a DC generator, whereby the current flows only in one direction. So that would be a DC generator. This is because our device has a split ring commutator instead of just slip rings here. As a split ring commutator there. So that would be 1, 2 there. So the split ring commutator is reversing the current every half a cycle to give us a current that only flows in one direction there. Okay. 10.3, name the principle on which the generator works. The generator functions on the principle on Faraday's principle of electromagnetic induction. This will be electromagnetic induction. The principle of operation of a generator is electromagnetic induction. When a magnetic flux linked to the coil changes, an EMF is induced in the coil there. The magnitude of the induced EMF is directly proportional to the rate of change of magnetic flux. That is Faraday's law of electromagnetic induction. That's the principle on which the generator is based. Okay, 1 for that. And then 10.4 here says, which one of the following ROS represents the voltage output of the generator identified in question 10.2. So which graph represents the output voltage for a DC generator? Remember now, direct current, we're looking for a graph output that shows current flowing in only being produced in only one direction, with a voltage being produced in only one direction here. So you can see there, this one over here, the output does not change. It's only maintained on one side of the vertical axis there. It does not change direction like this one over here. So it just goes from 0 to peaks, but without changing direction there. So at the point whereby the coil is perpendicular to the direction of the magnetic field, we have that 0 output voltage, and then we get a parallel. We get it to be the coil. When we get the coil to be parallel to the direction of the magnetic field, then we have the maximum, the peak there, voltage output there, and then it goes on and on like that, but without changing the direction there. What we see on the left hand side, that the voltage there is not just only going from 0 to peaks, but it keeps changing direction. As you can see, it keeps going towards the negative vertical axis there. Okay, so the answer is S. This one is R and this one is S, so we choose S. And 1 mark for that, and this will be an activity out of 5 there. How did you do out of 5? Okay.